Hi, everyone. So welcome to the first lesson of the last unit. I know, crazy. So it's all the pieces of the puzzle. And think about why that is, right? It's literally what we're doing today is just it's a puzzle. It's a puzzle. it's a thinking kind of mind bender kind of thing. So we're on page 171. This was our do now. So if you did not do that, if you if you did not do that now, please do that. Oh my goodness, what is wrong with me? So here on the right hand side, you'll see a lot of the work. Oh, I didn't really highlight any of the answers, so let me do that for you. So make sure, please, as it says right here, to convert each logarithmic equation to an exponential one. So logs to exponential. And so if you remember the triangle of power, at first I was like a little hesitant about this, but I really do like it. So the way you see it, so if you look right here, so it's 10.1 and then x, right? That's how you're going to write it, 10.1 and then x in this direction, in this counterclockwise direction, right? So 10.1, then x. So, and that's how you would, and then so the exponential form would be 10 to the x power, right? See how like this looks like that, 10 to the x power is equal to 1. So I always like to circle these two to help me to see that those are the exponents, or that's the exponential form, you know what I mean? So 10 to the x is equal to 1. And the way I like to see this is, remember 0.1 is the same as 1 over 10. Thus the name 1/10. And so what could x be, right? And then some people had said that was going to be -1. If you remember, anything like to the -1 power just means that it's like that fraction, 1 over 10. Technically to the 1 power, but we know 10 to the 1 power is 10. All right, and then same thing with the next one. So please work on those if you have not already. So here's the answer here. This should be 4. Again, do your triangle of power. So 2 on the left, we always start on the left, 2, 16, and then up top is x, whatever it's equal to. If you remember, the log is the exponent. So therefore, that's why you see that whatever it's equal to is the exponent, right? And the next one is going to be 9. This one is really important. We're going to keep on thinking about this idea of number 3. So it's going to be 10, then 10 to the x is equal to 10 to the 9th. Well, what in the world would x have to be so that it would equal 10 to the 9th? 10 to what power would equal 10 to the 9th? And you're like, well, Leslie, isn't that kind of like a duh kind of question? Like, yes, it would have to be 9, right? Because if it was like 8, 10 to the 8th, how is that going to equal 10 to the 9th? Or 10 to the 3? Is that going to equal 10? And no, the only number that's going to work is 9, right? Because 10 to the 9th is equal to 10 to the 9th. You're like, yeah, well, we're going to run into stuff like that. So we're going to expand on that idea. Okay, so understand it. Oh, and note, what if it was like 2 to the x is equal to 10 to the 9th? Could we just still say that that's 9? No, of course not. And you know that because you're like, wait, because that's not 10. So it has to be the same basis. Just saying. So this is not a thing. So it has to be the same basis. All right. So if you look at number 4, okay, this is weird. So I didn't do the triangle here. So let me do it here. So it's 2, 1/4, and then x. So 2 to the x power, 2 to the x power is equal to 1/4. All right. And so what I like to do is I like to think, okay, well, how can I get this to be the same base? Kind of like what we're talking about up here. Both of these were base 10. So I'm like, well, I can get this to be the 4 to be a 2 squared, right? But then my 2's on the bottom. So how do we get it to the top? Remember the power of negative exponents, right? So that's the same thing as 2 to the -2 power, right? So therefore, if it's 2 to the x is equal to 2 to the -2, well, x better equal -2, right? Just like how we said before. So there's our answer. So today for our learning targets, it's going to be convert exponential equations to logarithmic ones and go the other way, logs to exponents, right? And they are inverses of each other. Okay, so please understand they are inverse, they undo each other, exponentials and logs. Okay, we'll get more into that in the next couple of lessons. And then, and also we're going to solve exponential and simple logarithmic equations. Simple ones, we're not going to get too complicated. So what if there are 2 logs? We're not going to deal with that. just the one log right now. We're not going to do the other ones. If you're curious, feel free to look at that. You can actually work through them because they are meant to be worked through. It is interesting, but we're just not going to have enough time for this quarter to do that. All right, so here we're using the triangle power. Here is the little remember this thing for that. If you're not too certain about it and you're just converting them, okay? And so if it's exponential, convert to logs. If it's logs, convert to exponential. If you have not done that before, make sure you do it. And this is where you can check that, right? Or you can go to the OneNote or the class notebook and look at the annotations there as well. All right. Please make sure you're always writing your triangles. I mean, unless you can just do it in your head, you got it down pretty well. That's fine. That's okay. Just make sure that you're checking here that your exponent. So you see this 2 right here is what the log is equal to, because those should always be the same, whatever the exponent is, because remember logs are what? Are exponents. Okay, so those are that. And if you can see, this is like the triangle of power. See how the mini triangle of power, all right? So 10 and then 100,000 and then on top would be 5. See how it makes that triangle? Like a lopsided scalene triangle, but still a triangle, all right? Please practice that if you have not already. And if you notice right here, if you look at the fraction ones, it's exactly the same thing. Right? You're still making that triangle of power. Where's the triangle? Oh, did I not make that triangle of power? I didn't. Okay, so let's try this out. I'm going to use green for this one. Okay, so we'll do this guy right here. So again, so that's going to be 2/3 to the power of 3 is equal to 8/27, right? So if we're writing in logs, we're going to start with this one and go around this way. So it's log base 2/3, right? Of what comes next? 8/27. Of 8/27 is equal to 3. Okay, that's how we do that. Notice this is pointing to the power. Maybe that's why it's called the triangle of power. All right. And so that's what it's going to go. Also another one that was kind of difficult was this ln. Remember, ln is natural log, which means it has a special base. It's a log that has a special base. Remember what that base is? E, right? And remember, E was like 2.71828182845904523. If you don't remember how to memorize that, look at another video. But yeah, yeah, I'm not that smart. It's just you use like different memory thingies to help us with that. But anyways, so that's basically just log base E. So you can just use your triangle of power here. So that's base E, 20.086, and then on top is what it's equal to, which is about 3. Okay, it's always going to be approximate just because E is an irrational number, which goes on forever and ever. So you can decimal wise, you can never be exact. So again, that's going to be e to the third power. So e to the third power is approximately equal to 20.086. And if you don't believe me, check that on your calculator. All right. So there's the rest of them. All right. So we're going to go on to the next part right here. This just talks about the conversions between logs and exponentials, right? And I love how this is it's mind-blowing. Okay, so be ready. The highlighted part. You ready for this? A logarithmic equation is an equation that contains a logarithm. What? This is like, what? I was like, why did they write it like that? It's like so obvious, right? But yes, it's true. It's like, yeah, sometimes you just state the obvious and that's okay. You know, sometimes you're like, oh, that totally makes sense, but it's so obvious, right? And then right here, I really like this, so I boxed this one. So make sure you read this. I'll read it for you. I got you. So to write a logarithmic equation, sometimes it's helpful to consider the exponential form first, and then convert it to log form, okay? So that might be helpful. So here we wrote down, so if you want the challenge, you can try writing these. Okay, don't look at the screen. You want the challenge, try writing these in logs from the get-go, right? But if you're like, wait, this is a little bit hard. So like for me, logs are always a little bit hard for me. I love them, but they're a little hard. So how do we relate 49, 2, and 7 as an exponent, as an exponential, right? So, or in exponents, I guess. So it was like 7 squared is equal to 49. Yeah, that's true. 7 squared is 49. So now we're just going to change that to log form, right? If we have a triangle right here, 7 squared is equal to 49. So it's going to be log base 7 of 49 is equal to 2. Just like that. So this is our answer in logs. So do the same thing for all of them. You can see them right here, what they would be. Relate them. If you're doing things like this, oh, 4 to the 4th power is equal to 1. Yeah, you could do that just using all the numbers, but is it true? Is it true? No. So you can't do that. You can't just randomly put in things like that. So you have to make sure that it is true. And if you are starting with the logs first, then I would convert them to exponentials so you can make sure that you are correct, okay? Because it should be a true statement. So if you're doing this, so let's pretend like you're like, oh, what if it's log base 256 of 4 is equal to 4, right? I used all the numbers, right? Let's see if it's true. So we're going to do our triangle. So here's 256, 4, and 4. And we're like, okay, is this? So it's 256 to the 4th power. Does that equal 4? Yeah, no, doesn't, not at all, right? So then I know, oh, wait, I did this wrong. This is not the right way to do it, right? So we'll be like, oh, and then yes, this is the way you should have written it. Just like that. All right, but that's how you would check in any case. All right, so, oh, also another thing to note, this x is not an exponent, okay? So if we're doing log base 3 of x is equal to 2, I'm just saying, this is just means none of these on the left, right? Please make sure that your x is the same size as your log letters, because if it's up here, that's wrong, right? We're not doing any exponents. There are no exponents here, okay? I mean, log is an exponent, yes, but you're not writing anything as a superscript is what I'm saying, okay? None of that. So this is a no-go. That's bad. You need to write it like this. I had kids who were doing this, students who were like doing this. And I was like, why is it flying? You don't want that. Okay, so next one right here. Next page, we are on page 174, right? And these are 3 different like ways. I mean, it's exactly the same way. Just different things are unknown, right? So what if we didn't know the argument? What if we didn't know the exponent? What if we didn't know the base? Literally, you solve it very similarly, okay? And honestly, I wouldn't worry too much about this one right here. These two, when we don't know the argument and the exponent, these two are what we're going to look at the most. This one right here, we can solve it in another way that's much easier than the way they're presenting here. It's unnecessary. This is unnecessary work. All right, so if you look right here, notice all of them, what do? They change everything. Oh, they change everything to exponential form. Okay, and that's what this is talking about. So if ever you have a log and you're like, oh, I need to solve this, try exponential form. See what it can tell you, right? Because if you look right here, 4 to the 3rd power is equal to y. Oh, that's super easy to solve, right? You just plug it in your calculator, 4 to the 3rd power. Or maybe you already know that. Oh, it's 64, right? And done. See how that's easy? This one right here is a little bit more work, right? 4 to the x is equal to 64. Now you have to think about, well, what would that x have to be? What does that exponent have to be? And if it's a perfect cube, which this happens to be, that's great, but that doesn't always happen. And we'll talk about it in a bit. We'll have other ways to solve this one, just say. But the concept here of having the same base, remember we talked about number 3 in the do now, or the warm up, that's going to be important because we're gonna need that for more difficult problems. Okay, but we would be able to solve this actually even without. I mean, you can look on your calculator, right? If you have one that has other bases, you could actually just solve this right away. You don't even have to change it to exponentials, right? And you just do it. And you should just get the answer of 3. I would try that out now if you don't have that. And then right here, if you change it to exponentials, is b to the 3rd power is equal to 64. If you, b to the 3rd power is equal to 64. Well, we already know how to solve this problem, right? We solved this in like unit 4, right? The first unit of this quarter, right? which was what? How do we get rid of cubes? You cube root them. Then you just go to your calculator and be like, what's the cube root of 64? And you'd be like, oh, it's 4. See how they're doing it? They're trying to make, you can, this is totally fine. It's just like, why, when you can just cube root and not have to think that hard about it? I'm just saying, right? Because what if it's not a perfect cube, and then what do you do? Then you're lost. Yeah, so this is, remember, I'm just trying to tie it all in because they're all related. Just because we're in logs doesn't mean that we cannot use cube roots. We can totally do that, all right? It just depends on the situation. You just know more things now. Okay, so now we have these problems, and solve as many as you can. If you notice right here, our first step is what? Put it into exponentials. So that's what we did, right? 8 to the n is equal to 64. And some of you guys are like, well, that n has to be 2 because 8 to the 2 power is equal to 64, right? I said, let's practice getting the same basis, right? Just as good practice, because we know the answer should be 2. Right? So we're like, oh, well, 64 can be rewritten as 8 squared, right? And we're like, oh, well, then n definitely has to be 2, right? There it is. Here, okay, again, we're writing it in exponential form. So 2 to the negative 2, or n to the negative 2 is equal to 1/16. Always with fractions, it just gets a little bit weird. You're like, wait, what? And so what I like to do, well, let's try this out. Well, we know we need some kind of square, right? So I'm just gonna say, well, 16 I know is 4 squared, right? So we got the 2 part, but we want that to be not 2, we want it to be negative 2. So what do? So we're going to flip that, remember? So if we're getting out of the denominator, it is going to be a negative exponent. So it's 4 to the negative 2 power. Okay, that is part of your exponent properties. Review them if you don't know them already. And then we're like, okay, well, if the exponents are the same, then that means the base better be the same, right? Because they're supposed to equal each other. So that's why we say n is equal to 4. All right. And this one right here, if you look at C, again, if you have not paused and tried these yourself, I would pause and try these yourself and then unpause. And then here we go. So 1/2 to the n power is equal to 64. Now for me personally, I don't like dealing with halves because it's just like, it's hard for me to compare that with a number that's not a fraction, right? So I'm gonna make this into a not fraction, right? I can just write this as 2 to the negative n power. Remember, like how we did here? We wanted to get the negative, so we just brought it to the top. So we want, so we want to, it's a positive here, so to get it to be a, it's gonna be negative, just like that. All right, so we know that, and we know that our base is gonna be 2, so let's try making the 64 a base of 2, right? How many times do we need to multiply 2 by? 2 times 2, 4. 4 times 2 is 8, 16, 32, 64. 6 times. So we know that's going to be 2 to the 6th power. So just looking at this part, what in the world? So negative n is equal to 6. How do we get rid of that negative, right? And some of you guys who are more conceptual, like the negative of what will give me a positive 6. And if you said negative 6, and you didn't look at the answer, good job, because the negative of negative 6 is equal to 6, right? Because, you know, the negatives cancel out, but not a lot of people think that way. So here we go. You could either divide both sides by -1, because if we divide, because some people were saying, well, what if we divide it by negative n? I'm like, yeah, you can totally do that, 100%. But what do we get? Negative n divided by negative n is 1, is equal to 6 over negative n. Does that help me with anything? No. So yeah, don't do that. Like, it doesn't help, it just gives you more work to do. So we don't want that. So that's what we had said, divide by -1 instead. You can also multiply by -1, right? Because -1 times negative n is positive n, and 6 times -1 is -6. See how we get the same answer? And the way I usually, when I was a kid, a high school student, way back in the day, I always multiply by -1. You can divide by -1, that is perfectly fine. Another way you can do it, if you like to think about it this way, is I like to also just, in my brain, I would add n on both sides and then subtract 6 on both sides. Like I just flip them, right? And so if I do that, I get 0 is equal to n plus 6. Then how do I get rid of the plus 6? Subtract 6, right? So you see how this is a little more work, but you can totally do it. There's not just like, oh, you have to divide by -1. You don't have to do anything, right? As long as you get that rid of that -1 legally, mathematically correct way, it's fine. So you can multiply both sides by -1, or you can even add n to both sides and then subtract 6 on both sides. So n is positive, right? And then I know I can just switch them. So n is equal to -6. See, same thing. Either way you do them. Any of the 3 ways that you've decided. All right, so let's try D. I didn't do this in some of the classes, so here we go. So remember, when we have no log, well, we have no log. When we have no base, it doesn't say what is that number. 10. Okay, so this is actually log base 10. So here's my triangle. I log base 10 of n is equal to -3. All right, so this is going to be my exponent. So 10 to the -3rd power is equal to n. This is easy. It's already solved for n for me. So happy days. What's 10 to the -3rd power? That's just going to be -1 over 10 cubed, which gives 1 over 1,000. If you leave it as 1 over 1,000, that's fine. If you want to put it in as a decimal, either way is okay. So I like to use fractions just because it's more accurate, unless it's like 0.001, which is exactly the same number. But if you're like dividing by 3, then you get like these weird repeating numbers. Yeah, and then it's not exact. I don't like that. I like to be exact, very precise. All right, and same thing with this one. Let me try a different color. So here's my triangle. So n, 27, oh, 9, 27, and n. So it's going to be 9 to the nth power is equal to 27. So, okay, I can't get 27 to have a base of 9. Like 9 to what power will be 27? I can't do that. So what I can do, and I know like, yeah, so what I can do is go 3 squared, right? Let's make it a little smaller. 3 squared to the n power, because remember 3 squared is 9. Well, what is 3 to what power will be 27? 3rd power. So hopefully you know your perfect cubes. If you don't, we will now, because we're going to go over those all the time. We're like 27 is 3 cubed, right? And then remember power to a power, right? Power to a power means that it's going to be, what are we doing to those exponents? And if you don't remember, this is what I always did when I was a kid. So I was like, okay, I know 3 to the 5th power squared. So what's that going to be? That means it's 3 to the 5th power times 3 to the 5th power. So how much is that? That's 3 to the 10. I have 10 3s that I'm multiplying, right? So how would I get that? Oh, I'm multiplying. So that's, I'm like, oh yeah, multiply. All right, so it's going to be 2 times n. So this is actually going to be 3 to the 2n is equal to 3 to the 3rd power. So the bases are the same, remember? So that means those exponents better be the same. So it's going to be 2n is equal to 3. Well, what would that n have to be? Just divide both sides by 2 and we can find out. Or maybe you already know in your head. You're like, 3 over 2. There you go. You're like, n could be a fraction. I'm like, n could be whatever it wants to be, right? Yeah, n could be fractions. I don't know if you knew that, but that's totally a thing. So if you were to plug that back in there, if you go 9 to the 3/2 power, that's what it'd be. Honestly, if we want to really make that connection, 9 to the 3/2 power, let's think about that. In radicals, what would that be? That's 9 to the 3rd power and then square root. Ooh, that doesn't look good. You know what I would do? I would just go square root of 9 and then do that to the 3rd power. That would look easier, because what's the square root of 9? 3. And then what to the cube of that? 3 times 3 times 3, which we know is 27. There we go. Same thing. If I could have cubed it, but that's just a really big number that I cannot do in my brain. But you can totally check that. And it'll be the same thing. Either way is fine. That's back at the first unit that we did in this quarter, right? Alrighty, next one. So log base n of the cube root of what in the world? So let's try this triangle. Okay, triangles are less threatening. So n here, and then the cube root of 49 here, and then up here on top is 2/3. So let's try that out. So this is going to be n to the 2/3 power is equal to 3 square root of 49. Okay, well, well, remember we were talking about these, right? Let's convert that cube root to a fraction, like to an exponent, right? We know how to do that. So this is going to be n to the 2/3. Well, with 49 is just same thing as 1 over 3. Like the cube root, same thing as 1/3. So far, so good. Well, we want 2/3. We don't want 1/3. So we can't, like, there's nothing we can do, but we're like, oh, wait, 49. We know about 49. Well, how can we write that as a square? Right? So we know that this is going to be 7 squared to the 1/3 power is equal to n. So remember what we do with these exponents again? We multiply them. So that's going to be 7 to the 2/3 power is equal to n to the 2/3 power. So what's n? N's got to be 7. Same bases, right? They have to have the same bases if the exponents are exactly the same. So there we go. Done. Just like that. All right. That was the end of the lesson. Again, if you're curious about the other stuff, it is interesting. Just stuff that we can't really go over. So I'll see you later. Bye. I can see that stop button.